For this build you'll need a breadboard, an Arduino, an on-off push button switch, and I've got a self-locking one, a buzzer, 4 220 ohm resistors, 2 10k resistors, an LDR, a 3 volt laser diode, and 4 LEDs. I've gone for red, green, white and blue to stay faithful to what I'm trying to create, but you can pick any 4 colours you want really. And also you'll need a bunch of jumper wires. Okay, so this is the circuit that we're going to be making. So here with this red LED, that's actually going to be our laser diode. It's just that they don't have that option available in this program. And obviously over here, I showed you the on-off button I'm going to be using. It's going to be different to this, which is just a placeholder push button. Essentially how it's going to be working is when the circuit is active, you'll have our laser diode shining onto our LDR. That will decrease the resistance, which will then be recognized by this wire going to our A0 pin, which is an input pin, and that's then going to tell our Arduino that everything's good. When there's a break in this detection, when the LDR doesn't detect the laser because something's in the way, the resistance is going to increase, and then that's going to be detected, and through the A0 pin that's going to be detected by the Arduino, and that's going to activate our alarm system, which is obviously our flashing lights and our siren sound, and we can reset with our on-off button. So I'm going to start by hooking up the breadboard to my power supply, and when I run the build it's going to be 5 volts from the power supply. So first you want to place in your LEDs into the breadboard. Then you want to place down your buzzer and just pay attention to the fact that there's a positive and a negative end. The longer one is positive in this case. So next you want to place down your LDR. And I've placed it in the E and F rows. So now you want to start connecting the positive pins of your LEDs into the breadboard. So plug the red into pin 4, the green into pin 5, the white into pin 8, and the blue into pin 7. So now you want to take your 4 220 ohm resistors and use them to connect the negative leg of your LEDs to the negative power rail. There's something that some people don't know who are starting out, that it doesn't actually matter whether the resistor goes before or after the LED, it will still work just the same. So then you want to connect the positive end of the buzzer to pin 12 of the Arduino, and then connect the negative pin of the buzzer to the negative power rail. Next you want to take a jumper lead and put it from the positive end of the power rail to one side of the LDR. Then you want to take a jumper wire, place it in the same column and connect that to the A0 pin for your input. Then you want to take one of your 10k resistors and connect that from the same column that the LDR is in and connect that to the negative power rail. Now you want to take a jumper wire and place it from the 5 volt pin of the Arduino to the positive power rail of the breadboard, and take another jumper wire, connect it to the ground pin of the Arduino and plug that into the negative power rail. So now I'm going to solder the 3 volt laser diode to some of the jumper wires so we can plug that into our system. Then you want to take the positive red wire and connect that to the 3.3 volt pin. Then you want to connect the blue wire to the other ground pin of the Arduino. And I've done the same where I've soldered jumper wires to the switch as well. To connect the switch, what you want to do is take one jumper wire from the positive power rail and connect that to somewhere else in the breadboard. And then in that same column you want to connect the positive end of the switch. And then you want to take another jumper wire a few spaces over and connect that to the breadboard and connect the other end to pin 6 of the Arduino. Now once again in that same column you want to get your other 10k resistor and connect that to the negative end of the power rail. So when you've done that, it's time to upload the code. So the code you'll find as well in the description down below. So you can see in the code down below where it says threshold. You can alter the system slightly by changing that number, but I'll explain that slightly later. So you want to upload the code into the Arduino and you should be good to go. So now as an example, I'm going to start up the system by turning on my 5 volt power supply. And just turn the lights off so it's easy to see. So you can see that the green light is on, which means it's not currently armed. And you can see that the laser diode is activated and it's pointing at the LDR. And I've just got that secured by one of the helping hands. So if you double click the button, then it should switch to the red. Then the green LED should turn off and the red LED should turn on. And that means that the alarm is now armed. Now that means if something comes between the laser and the LDR sensing it, then the alarm should be triggered. So you can see if I put this pen in between, the alarm starts flashing blue and white, and the buzzer starts going, like a siren. To deactivate the alarm, I'm going to press the button again. Essentially what's happening is the green unarmed state and the red armed state, it'll be constantly switching between those two states, and you just use a button to control which state it's going to be in. When it's green, then if you put anything in between the laser and the LDR, then the alarm won't be tripped. So the three main factors you might have to consider when you're setting this up practically. So you can increase the distance between the laser and the LDR, but then you also have to balance that with the sensitivity, which is partially determined by the threshold set in the code, and it's partially determined by the light levels that you set up the project in. So currently I've got it in the dark, but if I did this in the light, then it might not work at a certain distance. So those three things are something you have to play around with. You can increase the sensitivity by decreasing the number in the threshold in the code, or you can decrease the distance. So the current distance I've got the laser and the sensor set up at are 10 centimeters, just for reference. Or you can change the light intensity of the environment that you've set the alarm up in. Yeah, that's all for this video, so thank you for watching, and if you've got any comments or suggestions, please leave them down below. Thanks for watching, and goodbye.